Welcome to Study Loop.
Hello friends, here it is given. Two-evaporator compression, refrigeration cycle with refrigerant 134A. We have to calculate power required for compression and coefficient of performance. Let us see here. Using table A11E, 12E and 13E for fluid properties. In third state, pressure is 180 psi. Fluid is saturated liquid. Enthalpy is 51.51 BATU per pound mass. At state 4 and state 6 and state 3, enthalpy of the fluid is same, 551.51 BATU per pound mass. That is the throttling process. At state 5, pressure becomes 30 psi. Fluid is saturated vapor. Enthalpy is to be 105.34 BATU per pound mass. At state 7, pressure is 10 psi. Fluid is saturated vapor. H7 is equal to 98.69 BATU per pound mass. The mass flow rate through the high temperature and low temperature evaporator are found. High temperature and low temperature evaporator are found. Rate of transfer of heat at low temperature M1 into change in enthalpy in the process 4 to 5. So it is to be. Now substitute the value. 9000 BAT pound mass upon 105.34 minus 51.51 BAT per pound mass. This unit I have to correct, BAT per second. Sorry, BAT per hour. So mass flow rate you will get 167.2 pound mass per hour. Similarly, for second evaporator it is to be QL2 at 7 minus S6. It is given 24,000 VAT per hour as given in the problem. 98.69 minus 51.51, so it is 508.7 pound mass per hour. To calculate, enthalpy at state 1, apply energy balance to the point. In the system, where the two-evaporator streams are recombined. Mass flow rate of evaporator 1 into enthalpy, mass flow rate of evaporator 2 into enthalpy to be total mass flow rate into enthalpy at state 1. So from here, H1 you will get M1 H5 plus M2 H7 upon M1 plus M2, putting the values as given above. Hundred 33 pound mass, sorry, VATU per pound mass. So pressure at state 1 having 10 psi. H1 already we have calculated 100.33 BATU per pound mass. So and trophy to be 0.0233 VATU per pound mass. Remember, pressure P2 is 180 psi, S2 is equal to S1, so H2 enthalpy to be 127.06 VATU per pound mass. The power input we can calculate. Total mass flow rate of refrigerant into change in enthalpy from state 1 to state 2, that is 167.2 plus 508.7 into 127.33 minus 100.33. Converting this value into kilowatt, so 1 kilowatt upon 3412.14 BTU per hour. So we will get the answer to be 5.293 kilowatt. Coefficient of performance of refrigeration to be rate of transfer of heat upon total power input 24,000 plus 9,000 BTU per hour upon 5.293 kilowatt. Converting it, it becomes 1.83. That's all for it. Thanks for watching it.